Hi, my name is Adam Cohen, and this is my video on logarithms. The first thing we're going to talk about is the basic notation of a logarithm. So we're going to have log, like a log of wood, with a base term, we'll call that A, a term here which we'll call B, and it's going to be equal to another term we'll call C. So this notation confuses a lot of early math students because you've never seen it before, you don't know what goes where, and basically what this is equal to is A to the C is equal to B. These two statements are equivalent. And the way we can remember what goes where is by taking the subscript term for the logarithm, which we called A, and going around the world. So we go from A, around to C, around to B. So you can see we go A, C, B. Hopefully that's easy enough to remember. If you have trouble with that, you can ask for help in the comment section. I'll be glad to respond. The next thing we're going to talk about notationally is the different type of logarithms you might see. So we can have log with a base A, like before, and that A can be any number, doesn't really matter. We can have just log, which you won't really see in math classes per se, but if you take, say, chemistry or a course that requires math but isn't a math class, you might see this. This just means log 10, so A would be 10. It's kind of similar to scientific notation, how we would say like 5 times 10 to the 5th power is 500,000. And the other one we might see is ln. ln is log with a base of E. And E is Euler's number, which is 2.7-ish. For now, let's not concern ourselves too much with what E is and why it's so special. That can be another video later. All we need to know is that ln is a log with base E. So that's basically all I wanted to cover in this first part of the video. I'll see you in the next one. So the next thing I want to cover is adding and subtracting logarithms. Now, when we have logarithms of the same base, here's what we can do. For example, say we have ln of 5 plus ln of 10. Notice how these are two logs that have the same base. They're both natural logs, but their inside term is different, and they're being added. What we can do is, instead of leaving it like this, we can make it one logarithm. And the way we do that is we keep the log the same. It's still ln, but we're going to multiply these two terms. So that makes ln of 50. So it's important to remember that. When the logs are separate and being added, we can combine them by multiplying the inner term. And if we wanted to separate this, we could break it back up. It doesn't even have to be broken up into 5 and 10. We could separate this into ln of 2 and ln of 25, and we're adding them. So it's important. When we're adding separate logs, they multiply when they're together. On the other hand, say I were to give you log 5 of 7 minus log base 5 of 9, right? When we subtract, we're going to divide. So just remember, addition and multiplication go together, subtraction and division go together. So this is going to be log base 5 of 7 over 9. It's important to note that the term that came first, the 7, is in the numerator. The term that came second, the 9, is in the denominator. So an important thing to note as well is we could always rearrange this as negative log base 5 of 9 plus log base 5 of 7. And now you're probably saying, well, now they're being added, so would I multiply? And yes, you would. Negative log base 5 of 9 times 7, so that's 63. And if you plug them into your calculator, this and this are the same thing. I'm not going to do that right now because I don't have a calculator on me, but I will leave that to you. All right, so next up on the list of things to cover is logs where we have an exponent. So here we have ln x with a power of 2. So this might get a little confusing because logs are made to find powers. But all we have to do when we have a term up here is just bring it down to the front. So ln of x squared, and bring this 2 over here, is equal to 2 ln of x. Doesn't matter what the exponent is. We could have ln of, say, square root of x, which is also equal to ln of x to the 1/2, if you didn't know that. Square root is the same as multiplying or raising a number to the half power. We can bring that down as well. So this is equal to half ln of x. All right. So basically, this is a very useful thing because we can get rid of powers, and getting rid of powers is always nice. Much rather multiply something by 2 at the end than square it and then do a log with it. What we can also do is say we have the function y equals e to the x. We've all seen this in algebra. It's the curve that goes like that, and no one likes it because it's annoying. We have to use that weird E button on our calculator. But say we wanted to solve this for x. The way we can get rid of the base term of a power like this is by taking a logarithm. Now you have to use the logarithm with that base. So since we're talking about e, we can take the ln, natural log, of both sides. Now, I'm going to write it down here, but just know that that's bad notation. I ran out of space. So ln of y is equal to, the ln and the e are going to cancel, and we're just left with x. Now, say we wanted to get back to what we originally had. We can make both sides powers of e. So I can make this e to the ln of y and e to the x. The e and the ln are going to cancel, so we're left with y equals e to the x. So that covers most of the power principles of logarithms. There are various complications that make this a little trickier. And once again, if you have any problems that come up that you don't know how to solve, leave them in the comment section below and I'll be glad to help you.